Hello everyone, I'm Siddharthan. This is the 15th project video in our machine learning project series, and in this video we are going to discuss about Titanic survival prediction using machine learning. So Titanic survival prediction is one of the classic machine learning use cases. Whenever a person starts to learn about machine learning, he or she will definitely come across this particular use case. So in this video, let's dive deep into this particular topic. So first I'll explain you what is the problem statement that we are going to discuss, and after that I'll explain you what is the workflow which we are going to follow. Okay. So and then we can get into the coding part. So that will be the steps that we follow in this video. Okay. So let's get started. So first of all, let's understand this problem statement. So every one of us know about the Titanic incident. So we all would have watched the Titanic movie where it is all about ship sinking due to an accident with the iceberg, right? So in this data set, we have several data points on the passengers who have traveled in that particular Titanic ship, and based on the few parameters, we are going to predict whether that person has survived the Titanic accident or that person didn't survive the Titanic accident. So this is what we are going to do in this particular project. Okay. So as I told you, so whenever you start machine learning, you will definitely come across this project, and there are these basic projects like Titanic survival prediction and house price prediction, and these basic use cases lets you understand what is the procedure we follow in machine learning and what are the different steps we follow to handle a data set when we are using it to train a machine learning algorithm. Okay. So these basic use cases are also important when we are studying machine learning. So now let's discuss more about the workflow which we are going to follow. So the first thing we need is the Titanic data set. So the data that contain all the passenger details who have traveled in that particular Titanic ship. And once we have the data, we need to process this data. So we cannot feed the raw data to our machine learning model. So we need to do some processing. So this data set will contain some missing values. So we will also discuss how we can handle these missing values. And after that, we will do some data analysis. So in this, we try to visualize the data. So like what is the data is conveying. I'll give you an example. So let's consider this Titanic accident. So it's logical to say that when something like this happen, children and women will be given first priority to be saved, right? So those people will be saved, and those can be understood by using this data analysis part, where we will try to plot the data in some plots and graphs. So that will be our third step, which is data analysis. So after we analyze the data, we will split the data into training data and testing data. So this is very important step in any machine learning use cases you take. So the original data has to be splitted in this two types. Okay. So once we split this data, we will use the training data set to train our machine learning model. So in this case, we are going to use a logistic regression model because this is a binary classification case where we will classify whether the passenger has survived or not. So there are only two classes, survived and not survived. So we will be using a logistic regression model because logistic regression works well in binary classification classes. Okay, so in cases, and we will use this training data to train our machine learning model, and once we train our model, we will use the test data to evaluate our model. So this evaluation step is to check how well our model is performing, how well the model is making predictions. Okay. So these are the 6 steps which we will follow in our machine learning project in this video. Okay. So while implementing the logistic regression model, I'll give you a brief explanation on how this logistic regression model works also. Okay. So this is the steps which we are going to follow in this video. So now let's get started with the coding part. So we will be doing all the coding in Python. Okay. So we will be doing all the Python programming in Google Collaboratory. So if you are new to this Google Collaboratory, or if you haven't heard about this, you can just go to Google and search as Google Collaboratory. So you will get to this particular environment where you can run Python programs. So before starting with the coding part, so I would like to give you a quick introduction to my YouTube channel. So if you already know about my channel, so you can skip this part. Okay. So if you are watching my videos for the first time, so I'll explain you what I'm doing in this particular channel. So in this channel, I'm making a project based machine learning course. So if you go to my channel, so you will see this machine learning course curriculum video. So in this channel I'm making a machine learning course, and you can download the course curriculum file from the description of this video. So in this video I've explained what are the videos and the modules I will be covering in this course. So if you want to start learning my course from the beginning, just go to the playlist section. So in the playlist section you can see this hands-on machine learning course with Python. So far we have completed about 4 modules, and we are currently in the 5th module, which is on mathematics for machine learning. Okay, so it is the 5th module, and also I will be posting one machine learning project video every Friday. So if you want to learn about several machine learning projects, so go to this machine learning projects playlist. So there are about 15 machine learning projects already. So okay, so you can watch these videos, and if you want to watch my machine learning course videos, you can go to this hands-on machine learning course. Okay, so every Friday I'll be posting machine learning project video, and on Monday evening and Wednesday evening I will be posting videos on this machine learning course. So this is all about my channel. So I'll give the link to my LinkedIn account, Facebook group, and Telegram group in this video description, so you can join those social media handles. Okay, so with that being said, let's get started with this particular Python. Okay, so the first step will be to import the dependencies. So whenever you are doing some Python projects, the first step is importing the dependencies. So the dependencies are nothing but the libraries and the functions which we need for that particular program. So I'll just make a text here as importing the dependencies. Okay, so let's import some basic libraries as NumPy and Pandas. So I'll import NumPy as NP and Pandas as PD. So these are two basic libraries that we use in machine learning, and I'll import two another libraries. They are matplotlib. So I import matplotlib.pyplot as PLT and import cborn as SNS. So this NumPy library is used to make NumPy arrays. So create NumPy arrays, and Pandas library. So Pandas is used to create data frames. So data frames are a structured table. So if we load our data set into these data frames, it is easier to analyze the data and process the data. So that's why we need this Pandas library, and Matplotlib library and Seaborn library are a data visualization library. They are very useful to make plots and graphs. Okay, so you can see here I have imported NumPy in the short form as NP. So whenever I want to use this NumPy library, I don't have to import it as NumPy. So I can just use this NP as a short form. So that is what we are doing. So instead of using matplotlib.pyplot every time, so we can just use PLT. So this is the abbreviating the library and importing. So these are the 4 basic libraries, and we need some other functions as well. So from sklearn dot model selection, let's import train test split. Okay, so this train test split function is used to split our data into training data and testing data. So I have already mentioned you in the workflow that we will split our data into 2 data sets. So one is training data and testing data, and this train test split function is used for this purpose, and we are importing it from sklearn.model selection. So this sklearn is one of the important machine learning libraries. So this library contains several data pre-processing function and also several machine learning algorithms. Okay, so this is one important library in machine learning. So we have imported this train test split function. Then I'll import my logistic regression model from sklearn dot linear model. Let's import logistic regression. Okay, and then finally we need to import from sklearn dot metrics, import accuracy score. Okay, so this accuracy score is used for evaluating our model to find how many good predictions or correct predictions our model is predicting. Okay, so this is the first step, which is importing the dependencies. So in order to run this particular cell and go to next one, you can press shift plus enter. So it will execute this cell and go to the next one. So the next step will be data collection. Okay, so the next step is data collection and processing. So now we need to get this Titanic data set. So this Titanic survival data set is available in Kaggle. So you can go to Google and search as Titanic survival data set Kaggle. So you will see this Kaggle site. So just go there. So this site is Titanic machine learning from disaster. Okay. So Kaggle is one of the important sites for machine learning, experts and data scientists. And Kaggle conducts several competitions where you can participate and make better machine learning models and do predictions. So you can check this Kaggle website, and this Kaggle website contains a lot of data, so several data sets. So for this, we are going to use this Titanic machine learning from disaster. So you can just go through this overview to understand what is all about this data set and what is that we are going to predict. Okay, so as I've already told you, our end goal will be to predict whether the person has survived or not. So you can go through all the description of the data set here. So to download the data set, you need to go to this data column, and here you will find the option called as join competition. So you can only download the data after you can after you have joined this competition. Okay, so in this data, you can go to this train.csv. So this is the data set which we need, and there you can find this download option. So go to this train.csv. So after clicking it, so you can download it from here. So your data set will be downloaded. So you just need to sign up to Kaggle before downloading it. So this will download our data set. Now we can upload this data set to our Google Collaboratory environment. Okay, so you can see the various features of the data set. Okay, so the various details regarding the data set. So these are the different columns we have. So we have this survival column. So this survival column contains the value as either 0 or 1. Okay, so 0 means the person has not surveyed, and 1 means the person has surveyed. So let's just upload the data in the Google Collaboratory, and let's come back to this particular table and understand more about this data set. Okay, so this is about data collection and processing. So here you can find this files option. So before running a Python program, so there will be this connect option here. So you need to connect your system here. After that only you can execute this programs. So after that, you can go to this files option. Okay, so in this files option, you can click this upload to session storage option, or just right click here. So you will find this upload option here. So I have already uploaded my dataset, which is train.csv. So csv means comma separated value. So it is one type of file. So we need to load this file to a pandas data frame. So as I have told you earlier, pandas is used to make a data frame. So data frames are structured table, so it is not easy to analyze the data from a csv file. So we will load this data to a pandas data frame and do the analysis and processing. Okay, so what I'll do is, so I'll just copy the path from here. So you'll find this options symbol here. From there you can copy the path of the dataset file. Okay, so now what we are going to do is load the data from CSV file to pandas data frame. Okay, so let's name the data frame as Titanic data, and Titanic data is equal to, so we are going to use this pandas library, right? So we have imported pandas as pd. So pd dot read csv. So this read csv is the function which will read the csv file and load it to a pandas data frame. So you need to mention the codes inside this parenthesis, and there you need to paste the path which you have copied. Okay, so we have already copied the path, so I'll just paste it here. So now you can run this. So this will load your data set from the CSV file to a data frame named as Titanic data. Now let's print the first 5 rows of the data set to see what are the different rows and columns the data set has. So this is about printing the first 5 rows of the data frame. Okay. So I'll mention this Titanic data now. So this Titanic data is the name of our data frame which we have created here. So Titanic data dot yet. So this yet function will print the first 5 rows of our data frame. So these are the first 5 rows of our data frame, and we have the passenger ID, and we have this survived column, and we have the P class, so passenger class, and we have the name of each passenger, and we have the sex, the gender of the passengers, and what is their age. And so we have some column like SIB, so we will discuss about it in this description of this data set. And we have another column called as parts, And then we have this ticket column, which gives the ticket number of the passenger and what is the ticket fare and their cabin details and embarked. Okay, so let's understand what are these different columns. So you can again come to this data set. So I'll give the link for this particular data set in the description of my video. So from there you can download the data set. So you can see the data dictionary here. So we have a survival column, right? So it is about, it tells whether the person has survived or not. So this survival column has values as either 0 or 1, right? So here 0 represents the person did not survive and 1 represent that the person has survived. Okay, so in this, you can see these are the first 5 rows. That means 5 different passengers. So in that, if the first value represents the person has not survived, and the second value represents the person has survived. So similarly, it is for each single passenger. So each row represents the data for each passenger. So the name of the passenger is given here. So you again, next we have this P class. So what is the ticket class? Whether it's first class ticket, second class, or third class ticket. So we know that first class ticket would be higher and second class would be lower than that. The ticket price would be, right? So it is given in the P class, and we have the values as either 1, 2, or 3. Okay, so these are the three values which we have. Okay, so you can see here we have the values as 3, 1, and the other value is 2. Okay, so we have three values here. And the next column we have as sex, which is on the gender of the passenger, and we have the age of the passenger in years. And we have this SIBSP column, right? So it is the number of siblings or spouse for that particular passenger in the ship. And then we have this part, so it represents number of parents or children with that particular passenger. Okay, and then we have the ticket number and what is the fare of that particular ticket and what is their cabin number and embarked. So embarked represents the port of embarkation. That means in which port the passenger has boarded the ship. So we have three embarkations here. So one is Cherbourg, Queenstown, and Southampton. Okay, so these are the three ports that we have, and so the embarked column will have the values as either S, C, or Q. Okay, so these are the three embarked stations that we have. Okay, so you can see more about this data. What is the different parameters of this data. Okay, so you can go through this. So now we can continue with our predictions. So the next thing will be to check how many number of rows and columns we have in our data set. So this will be to check the number of rows and columns. So for this, just mention the data frame name, which is Titanic data dot shape. So this will give the number of rows and columns we have. So totally we have about 891 rows and 12 columns. So we have discussed about the columns. So we have totally 12 columns, and the main column that we want for our prediction is survived column. So this is what we are interested in. So we need to check whether the person has survived or not, right? So this is our target variable, and the other columns represent features. Okay, so totally we have 12 columns. Of the 12 columns, 11 columns are features, and one column is target column, this surveyed column. And totally we have 891 rows. So 891 rows means 891 passengers. So each data point or each row represents one passenger in the ship. Okay, so these are the number of rows and columns we have in this data set. So now we can get some more information about the data. So I'll just put a comment here as getting some information about the data, and for this mention the data frame Titanic data dot info. So mention parenthesis. So it will give some basic information about the data. So totally we have 891 entries and 12 columns, and how many values we have. So null values means missing values. So you can see the value in this cabin as NaN. So NaN means not a number. So these values are missing in our data set. Okay. So non-null values means the values that are present. So null values means missing values, and non-null values means the number of values that are present. So totally we have 891 non-null values in this passenger ID column. And what is the data type in this each of this column? So the data type of first passenger column is nothing but an integer, 64-bit integer, and for this name and sex it is object. So they are strings. So name and this sex column are strings, so it is represented as object. So these are the details about the number of non-null counts and the data type of each column. So you can see that few values are missing in our data set. So you can see in this age column, and you can also see in this cabin column. So some values are missing. So now let's check how many missing values do we have in each of the columns. Okay. So this step will be to check the number of missing values in each column. So number of missing values in each column, and we can find it by Titanic data dot is null dot sum. So this particular line of code will give us the number of missing values in each column. So you can see here, so we don't have any missing values in the first five columns, the passenger ID, survived class, survived P class, name and sex. So, but we have 177 missing values in our age column, and about 687 values are missing in our cabin column, and only two values are missing in our embarked column. So totally, we have three columns that are missing the values. Okay. So we can check here that totally we have 891 rows. So 891 values should be present for each column. And out of 891, 171 values were missing for this. Whereas for cabin column, most of the values are missing. So out of 891, 687 values are missing, and we have only about 200 values, right? So you can subtract this 891 and 687. So only 200 values are present here. So now let's see what we can do with this missing values. So this step will be to handle the missing values. So I'll just make a text here as handling the missing values. So I have already made a detailed video on how you can handle the missing values in a data set in my machine learning course. So for the to see that video, you can go to my module 4 of my machine learning course. So and that module is all about data collection and processing. So in that I explained detailedly how you can handle the missing values. So let's see what we can do in this particular case. So first, let me take this cabin column. So in this cabin column, you can see the majority of the values are missing. So we cannot do anything with this particular cabin column. So we cannot find the mean of the column and replace it. So it doesn't make sense, because most of majority of the column is missing in this particular cabin column. So we need to just remove this particular column from our data set. So what I'll do is I'll just drop this cabin column from my data set. So I'll just make a comment here as drop the cabin column from the data frame. Okay. So what I'll do is I'll create another data frame, and I'll just give it the same name as Titanic data. So Titanic data is equal to, again mention Titanic data dot drop, and inside that mention columns is equal to, so what column you want to remove. So I want to remove the cabin column. So the caps should be the same. So you can see here, C is in caps, right? So you shouldn't do any changes in here. So you should just mention exactly what is the column name inside this parenthesis. So I'm going to drop this cabin column, and I need to mention another parameter, which is axis. So we know that we are dropping a column, right? So whenever you are dropping a column from a data frame, you need to mention axis is equal to 1. Let's say we are dropping a row. In that case, we will mention axis is equal to 0. So 0 represents row and 1 represents column. So here we are removing the column. So hence we are mentioning axis is equal to 1. So what we are doing is we are taking this Titanic data and dropping this cabin column, and I am storing this new data frame to the new data frame as Titanic data. So what I'm doing is just creating a new data frame with the same name, and in that data frame I'm just removing the cabin column. So that's why I've just given the same name. So you can give different name also, but it can be a little bit confusing. So that's why I just made the same name as Titanic data. So I'll run this. So now it will remove this particular column from our data frame. So now let's see what we can do with this age column. So in this age column, 177 values are missing from this 891 values. So about 700 values are present. Hence we cannot just drop the age column as we have dropped this cabin column, right? So now we need to do something with this age column. So now what we can do is replace all the missing values in this age column with the mean age of all the values. So what we will be doing is, so we will be taking this age column, and we will be finding the mean value for all the values in this age column, and that mean value will be replaced in all the missing values. So we will just take the missing values and replace them with mean. So let's see how we can do that. So I'll just mention this step as replacing the missing values in age column with mean value. Okay. So Titanic data, and inside the square bracket we need to mention the column name, which is age dot fill NA. So this is the function that will fill all the missing values. So NA means not available. Okay, so I'm going to fill all the missing values with the mean value. So I'll mention again the data frame name Titanic data age dot mean. Okay, and in place is equal to true. Okay, so what we are doing here is, so I'm taking this Titanic data frame and this age column and finding the mean of this column. So it is done by this particular function in the inside this parenthesis, and I am taking this mean value and I'm filling with this mean value all the non-available values. So I'm filling all the missing values with this mean value. Okay, so that will be stored in this age column, and in place is equal to true. So if you don't mention this in place is equal to true, so it won't be saved in your original data frame. So it will just what happens is, if you just remove this in place is equal to true, it will just replace all the missing values for this particular cell alone. It won't be carried out in the entire original data frame. So for that purpose you need to mention in place is equal to true. Okay, so let's run this. So this will replace all the missing values with the mean column. So I'll just after handling the missing values, I'll just print this line again and show you whether we have any missing values. So the next column which we need to deal with is embarked column. So we have only two values that are missing in this column. So this embarked column, we know that the values are it has only three values, right? S, C and Q. So you can go to this data details. So it contains three values which are C, Q and S. So the place where the person or the passenger has boarded the train. And now what we will do is, so only two values are missing. So we are going to find which value is repeated most number of times, and then we will replace the missing values with the value that is repeated most of the time. Because we cannot find the mean for this particular column, because they are in the form of categories, in the form of text, right? Characters, and we cannot find the mean for this particular column. So in this case we will find which value is repeated most number of times, and we will replace the missing value with this particular repeated values, and this value is called as mode value. So mode is nothing but the value which is repeated most number of times. So now let's find which value is repeated most number of times in this embarked column. So finding the mode value of embarked column. Okay, so print, so let's print the value as well. So print Titanic data embarked and dot mean dot, sorry, mode. So this will give us the mode value. So the mode is nothing but the value which is repeated most number of times, right? So you can see here the mode value is yes. So out of the three values C, Q and S value is repeated a lot of times. That means most of the people have boarded the ship in this Southampton port. So what we need to do is replace these two missing values with this value yes. Okay, so now what you can see here is we have the index as 0 and this index as the value as yes. So we just need to find this yes alone. So print this yes alone. So for this what I'll do is I'll just copy this. So once I copy this, if I mention the index which is 0, so the index of this particular value is 0, right? So when you mention it like this in the form of square brackets, it will give you the value as yes. So we will just use this value to replace with the missing value, which are two values are missing. Okay, so now let's see how we can do it. Replacing the missing values in embarked column with mode value. Okay, so Titanic data embark dot fill in a. So this will fill the non-available values, and need to fill the values with Titanic data embarked. So it's similar to how we have replaced with mean values. Everything is same. We just need to mention mode. Okay, so dot mode and 0. Okay, so mode 0 and in place is equal to true. Okay, so this will replace the two missing values with the mode value, which is yes. So it has successfully replaced the missing values. Now what you can do is check the number of missing values again. So in the previous case we have 177 missing values in age and 687 missing values and two missing values in these columns, right? Now let's see whether these values are replaced with appropriate values. So I'll just put this comment again here and run this. Now you can see here we don't have any missing values in our data set. So this is how you can handle the missing values in this particular data set. Okay, so it varies depending on the data set which we process. So it is not the same thing that we will do in all the data set. It depends on the data which we are handling. So in this case, this is the process which we can follow. And this is about data collection and processing. And the next step which we will do is data analysis. And in this data analysis part, we will try to plot the data in some graphs and understand what this data is conveying. Okay, so now let's get some statistical measures about the data. So we will do this in almost every data set that we have. So getting some statistical data, statistical measures. Okay, so statistical measures about the data. So Titanic data dot describe. So this describe function will give the statistical measures like mean, standard deviation, etc. for each column. Okay, so you can see here we have the count and the number of values in each column, mean value, standard deviation, minimum value, what are the different percentile, and what is the maximum value. So if you note here, it won't contain the data which are in the form of strings or text. Okay, so it just did the statistical measures only on the values or columns which has numerical data. Okay, so you can see that here. So we will get the values like mean, standard deviation, mean, percentile, and max. Okay, so this is about some statistical measures of the data. So it is not very useful when we have categorical column. So in this we have categorical column in the surveyed. So it is either 0 or 1 in this categorical column. And P class, it is also categorical because there are only three categories, 1, 2, and 3. And then we have this age column. So this statistical measure is useful in this age column, whereas it is not useful in categorical column because age is not a categorical column. So the two columns that are useful for finding the statistical measure is age and fair because they are numerical values and not categories. So remaining columns doesn't make any sense, much sense for us. Okay, but again it depends on data set. So some data set may contain several numerical columns, and in that cases we need to find the statistical measure. But in this particular case it doesn't make much sense. So you can just see this age column and fair column, and then you can go through this: what is the mean age of the passengers in that column, what is the mean fare of the passengers, and what is the standard deviation, minimum value, percentage, etc. Okay, so these are some statistical measures about the data we have. And then now let's the another step which we will try to do here is find how many people have survived and how many people didn't survive. We know that 0 represents the number of people who didn't survive and 1 represents the number of people survived, right? So now let's find that. So this is about finding the number of people survived and not survived. Okay, so these steps are very useful to understand more about our data. So we cannot just feed this data to machine learning algorithm as such. So we need to understand more about this data to get the idea of what the data has to tell. So now let's see how many people have survived. So mention Titanic data, and inside the square bracket mention the column name which is survived, and dot value counts. Okay, so let's run this. This will give us the number of values as 0, number of values as 1. So you can see here, so we know that 0 represents the number of people who didn't survive. So out of 891 passengers, 549 passengers didn't survive, and 342 passengers have survived. So this is the important insight we are getting, that the number of passengers who didn't survive are more than compared to those people who have survived the Titanic accident. Okay, so now the next step what we will do is about data visualization. Okay, so I'll just put a text here as data visualization. Okay, So now I'll just use the command sns.set. So this sns.set function is used to give some theme for our plot. So there is not much significance in this. So if you remember, we have imported this Seaborn library as SNS, right? So that's what I have used, sns.set, and we have imported this matplotlib.pyplot as plt. So we will use these libraries for our plots. So first, let's make a count plot. So making a count plot for survived column. Okay. So we have found here the number of values for number people survived and didn't survive. So now let's try to put this in a plot, in a count plot. So this count plot can be made using the cboard library, and the function that we use is sns.countplot. Okay, so inside that we need to mention what is the values that we are taking. So we are taking the survived column data. So from which data you are taking this? I'm taking this from Titanic data. So these are the two parameters that we need to mention. So data is equal to Titanic data. So let's run this. Now you can see the number of people who didn't survive, who are represented by the value 0, and the number of people survived represented by 1. And you can see that is here that the number of people who didn't survive is more. So this is the importance of it. So you can just visualize these values in these kind of count plots. So the next thing which we will do is, let's make another count plot. I'll just copy this, and this time let's check this based on the gender. So we have the column as sex, right? So sex column, which tells whether the passenger is either male or female. So let's replace this survived column with sex, and let's also replace it here. So now let's see the number of people survived. And here you can see the number of male who have survived and the number of female who have survived the Titanic incident. And you can also just copy this line of code here and see how many exact values are there. So here we may not get the exact value. So I just put the command here and let's replace the values. So I'll run this. So out of 891 passengers, about 577 passengers are there and 314 female passengers are there. So that is mentioned by this particular plot. So we can understand that a lot of male passengers are there than compared to female passengers. So that's what we are getting in this particular plot. So now what I'll do is, so let's check the number of survivors. So here we have found the number of survivors, right? And we found that about 300 survivors are survived. And now what we will do is compare the number of survivors based on the gender. So I'll just run this command, and it will make more sense at that time. So what we are going to do is number of survivors, hmm, based on, okay, so number of survivors gender wise, let me put it that way. So number of survivors gender wise. So again we need to make a count plot, sns dot count plot, and inside that mention the column which is sex, and we need to mention another parameter here which is u. Okay, so in this u I want the column as survived. So u is equal to survived, and I'm taking the data from Titanic data. Okay, so let's run this. So now you can see here, 0 represents the blue color, which is the number of people survived, and one orange color represents the number of people survived. So you can see the number of male here. So out of the 577 males, only around 100 male were survived the Titanic accident, and out of the 300 female, about more than 200 female have survived. So the important insight which we are getting here is, even though we have more number of males in our data set, the number of female who have survived the Titanic accident is more. So this is one of the very important insight that we can get from this data. So what it is, so in the time of this Titanic accident, females have been given more priority to be saved. So it is very logical, right? So whenever this kind of disaster happens, so the importance will be given for females and children to be saved first. After that only, the adult male would be saved. So that is what we are getting from this particular insight. So this is a very important insight that you can get from comparing this survived with this sex column. Okay, so Again, you can what you can do is, so use this particular method which we have did to plot the values for other columns as well. So now let's what we can do is use this p class column and make count plots. So I'll just copy this particular column, and so now we are going to make a count plot for p class. Okay, so I'll replace this with p class. Now let's run this. So we know that we have three values in this particular data point, sorry, in this particular column. So you can just go through here. So the P class has ticket class. So first class, second class, or third class. So we have three values here, and there are more people in this third class and less people in first class and second class. So similarly, we have just did this right. So find the number of people surveyed based on the gender wise. So we can now find the number of people surveyed based on this particular P class. So I'll just copy this line of code and I'll just put it here and just make some changes. So just replace this 6 with P class. So it will give us the number of people surveyed based on these three columns. So blue represents 0, which means the number of people who didn't survive, and orange represents 1, which is number of people survived, right? Okay, so we can see here the number of people survived in each class. So this is another important insight that we get. So you can similarly do the same thing which with other classes that we have. So we have this SIBSP column. So all the categorical columns. So you can also check the number of people embarked, right? So you can also find the count plot for this embarked columns just the same way that we did. So you just need to replace this column name with embarked and other columns. So try to find the plots for other columns as well if you want. Okay, so these are some data visualization techniques that we can do. So now we can do some more processing on the data, and after that we can go on with the training part of our machine learning. So now what we will do is, so here you can see this column called as sex, right? So this sex column has the value as male and female. So it is in the form of text, right? So we cannot give this data directly to our machine learning model. So we need to replace this text value to some meaningful numerical value. So what we will do is we will replace all the male values with 0 and all the female values with 1. So because like computers and machine learning algorithms understand numbers better rather than understanding text or characters. So we will replace this text value with numerical value. So we will replace this male with 0 and female with 1. So similarly we will replace this embarked column, right? So we will replace s with 0, c as 1, and q as 2. So those kind of values. And you can see here the name. So we don't need this particular name for our prediction, because like passengers aren't going to be saved based on their name, right? So this particular name column is not much significance for us. So we don't need this name column, but we need this gender column and embarked column. So these two columns are required. So we won't be dealing with this name column. So we will just drop this name column. So we will be taking the sex column and embarked column and replace it with numerical values. So these columns are called as categorical columns. And the step which we are going to do now is called as, so I'll just put a text here, and step is known as encoding the categorical column. So these are categorical column because they just contain categories. So either male or female. So it is in the form of category, right? So embarked has three categories, either S, C, or Q. So categorical column. So these are categorical columns, and we are going to encode it to numerical values. So let's see how we can do it. So mention the data frame, Titanic data. So actually we have did that already, right? So found how many number of male and female we have. Okay, so this one. So I need this line of code. I'll just put it here. So from this we can understand that we have just two values, either male or female in this particular column. So let's also check this for this embarked column as well. So I'll just put it here and change this to embarked. So because we need to know how many different values are there, so by running this value counts we can know how many different values are there. So in this column we have only three different values. One is S, second one is C, and Q. So now we need to replace these values. So let me make a comment here as converting categorical columns. So Titanic data dot replace. So this replace value will replace all the values that we want. Dot replace, and I'm taking this 6 column first. Okay, so in this 6 column, so you need to mention this curly brackets here. If the value is male, I want to replace this values with 0, and if the value is female, I want to replace them with 1. Okay, so this is what we are trying to do here. And now we are taking this for embarked column, and for embarked column we have 3 values totally, right? So for embarked column I want to change the value. So we have 3 values, so let's replace S as 0, C as 1, and Q as 2. So embarked, and if the value is yes, I want to replace it with 0, and if the value is C, I want to replace it with 1, and if the value is Q, I want to replace it with 2. Okay, so this is what we are doing here. So I'm just going to replace the values, and I'm taking the 6 column, and in that 6 column, if the value is male, I want to replace it with 0, and if the value is female, I want to replace it 1. Similarly, for embarked column, yes should be replaced with 0, C should be replaced with 1, and Q should be replaced with 2. So let's run this. And also we need to mention another thing. So we need to mention in place here also. I have already explained you why we need this in place parameter. So let's run this. Okay, so there is some syntax error here. So okay, so we just need to mention another curly bracket here. So okay, so now you can print the first 5 rows of the data frame, which is Titanic data dot yet. So we know that it will print the first 5 rows, right? So now you can see this 6 column and embarked column. So all the male values will be transformed to 0, female values to 1. Similarly, S will be replaced with 0, and C with 1, and Q with 2. So this is how you can encode the categorical columns. So we have did our processing. So the next step which we want to do is separate this target column and the other features. So as I told you earlier, the column which is of interest for us is survived, because we need to know which passengers have survived and which passenger didn't survive, right? So this becomes our target column. So we need to separate this column from our data set. So this step is all about separating features and target. So all the columns except this target becomes our features. So what happens is our machine learning model can predict whether the person has survived or not by going through these features. Okay, so this is our target, and the other columns like the P class, gender, age, siblings, parts, and fair, embarked are nothing but features, and this survived is nothing but our target column. So I'll create two variables as x and y. So in x, what we will do is take this Titanic data dot drop. So we are going to drop certain columns. So as I've told you earlier, so we don't need this name column, so it doesn't make sense. So we don't people won't be saved based on their name, so we will remove this name column. And this ticket number also didn't make much sense, so we will remove this ticket column, and also the passenger ID column. So ID is just the serial numbers for the data point. So we don't want these three values, which are passenger ID, name, and ticket. So they are just identity, so we don't need those values. So I'm going to drop them. So mention the data frame name, which is Titanic data dot drop. So I'm going to drop certain columns. So mention them in a list. So list will be enclosed in a square bracket, which we know. So I'll just create a list here. In this list, mention the columns which we want to remove. So first column which we want to remove is the passenger ID, right? Passenger ID. Okay, so the next column which we need to remove is name. So this is the column which we want to remove, which is name, and the third column which we want to remove is ticket. So we don't need these three columns, and also I'll remove this survived column. Okay, so what we'll do is we will remove the surveyed column and store all the data in this X, and we will store the surveyed column alone in this Y. So I'll also mention the surveyed column here. So surveyed, and mention axis is equal to 0, sorry 1. So as I have told you earlier, whenever we are removing or dropping a column, we need to mention axis is equal to 1, and whenever we are dropping a row, we need to mention axis is equal to 0. Now let's store this surveyed column in this variable Y. So Titanic data, and in the square bracket mention the column survived. So let's run this. Okay, so now you can print this X and Y and see. Let's print X, and this X won't contain all these four columns: passenger ID, name, ticket, and surveyed. And you can print the Y column here and see. So print Y, we can see that it contains all the values of surveyed column. So this is how you can separate data and features. Okay, so the next step which we are going to discuss is, as we have discussed in the workflow, which is splitting the data into training data and testing data. So splitting the data into training data and test data. Okay, so I'll create four arrays. They are X train, X test, Y train, and Y test. So these are the four arrays that we want. Okay, and I'll use the function train test split. So train test split. So X, Y. So I'll explain you what I'm doing in this particular line of code. So let me complete it first. So test size is equal to 0.2 and random state is equal to, let's mention 2. Okay, so what I'm doing is I'm creating these four arrays: X train, X test, Y train, and Y test. So I'm taking this X value and separating it or splitting it into training data and testing data. So this X will be split into two arrays, and those two arrays are nothing but X train and X test. Now what I want is, for this X train, I want the corresponding Y value, which is either the person has survived or not, right? So all those value will be stored in Y train and Y test. So X train contains the training data of X, and all the Y value corresponding to this X train will be stored in Y train. So what happens is, X will be split into two data sets, and correspondingly Y will be split into two data sets. So this X train and Y train are linked. So this X train contains some data, and Y train contains whether the passenger has survived or not for those data points that are present in X train. Similarly, X test contains a set of data, and the survived value for those passengers in X test array will be stored in this Y test. So that's why we are creating these four arrays. So for this, we are using this train test split function, and we have already imported this train test split function in our first cell, which is importing the dependencies, where we have imported this train test split function from sklearn dot model selection. Okay, so I'm using that now, and what I'm splitting is nothing but X and Y. So we need to mention X and Y in this train test split function, and here I mentioned test size is equal to 0.2. So 0.2 represents 20 percentage. That means I want 20 percentage of the data as test data. So 80 percentage of the data goes to X train, and 20 percentage of the data will go to X test. So out of 891 data points, 80 percentage will be in X train, and out of 891, 20 percentage will be in X test. So that's why I mentioned test size is equal to 0.2. In machine learning, we generally take 80 percentage. I mean, like in machine learning, we take either 10 percentage or 20 percentage of data as our test data. So that is the general convention that we use. So in this case, I have took about 20 percentage of data, and then we have this random state is equal to 2. So we need to mention one thing about this random state. So whenever we are using this train test split function, there is not a general rule how this data will be splitted. So the data will be splitted in a random way. So let's say that you want to split the data in the same way I am splitting. So let's say that we want that case. So now I mentioned this random state is equal to 2, right? If you mention the random state is equal to 3 or 4, your data will be splitted in some different way. So your data will contain different values. I mean, like the composition will be different. So all the values will be similar, but the composition of X train and X test will be similar when you run the code. But if let's say that you want to have the same composition x train and x test as my data is getting splitted, so in that case we need to have the same random state. So this is just to have, for the reproducibility of the code. So this is not that much significant, but the role of this is to get splitting the data in a common way or in the same way. So let's run this particular line of code. So this will split our data. Now let's see how many data points we have for x train, x test, and the entire data set. So I'll just print x dot shape, x train dot shape, and x test dot shape. So we know that x represents the original data point, the data point which is not splitted, and it contains about 891 rows or 891 data points, and 80 percentage of it, which is 712 data points, goes to this x train, and 20 percentage of the data of 179 values go to this x test. So this is how you can split your data into training data and testing data. So finally, we are in the model training part, where we will feed this training data to our machine learning model so that it can learn from this data. So this step is model training, and in this case we are going to use a logistic regression model. So logistic regression is one of the important machine learning or statistical model. Logistic regression. Okay, so and it is very useful for binary classification problem. So I'll just give you a quick brief explanation on how a logistic regression model works. Okay, so you can see here, this is how a logistic regression function looks. So we call this particular curve as S curve, or it is also called as sigmoid curve. So this shape is called as a sigmoid shape, and if you use this logistic regression function, so this is what you get. So whenever we use a line function, so we know that the equation of the line is y is equal to mx plus c, right? So whenever you use that y is equal to mx plus c equation, you will get a straight line, right? So we will get a straight line. So whenever you use a logistic regression function, you will get this kind of curve. So this is the sigmoid function, which is y is equal to 1 by 1 plus e power minus z. So this is the logistic regression equation. And now let's see what is meant by this z. So this z represents w dot x plus b. So this x is nothing but our input feature. So these are the terms which we have in our equation. So x is nothing but our input features. So in our case, the input features are nothing but the gender of the person, the sex column. We have the P class column, we have the ticket fare, and we also have the embarked column, right? So these values will act as our input features, and y is we know that y is nothing but our survived column, whether the person has survived or not. And we have this weights and biases. What is meant by this weights? So few columns will be more important for us than the other columns. Let's say that we have this male, sorry, the sex column, right? So this sex column can be very important for our prediction when compared to the embarked column. So those columns will have the weight values as more, and bias is, like an intercept. So for lines we have this y is equal to mx plus c, right? So c is nothing but that intercept. So b is nothing but that intercept value. I'll explain you more about this in detail when we deal with the machine learning model. So I'll make separate video on separate module on all these machine learning models. So in that I'll just explain you in detail what is meant by all these values, and what is the math behind this module. But just for this case, just understand how this logistic regression works. So we don't need to go much detail into this topic in this video, because it's out of the scope of this video. The idea of this video is to understand how we can implement this models. Okay, but we can just understand what are the various parameters we have. So we have this x as input features, which are our features, and y is our survived value, and w represents weights, and b represents biases, which is nothing but some intercept. Okay, so z value is given by this w dot x plus b, and when you put this z in this particular value, you will get y, and this y value will be a probability, prediction probability, and this value lies between 0 and 1. So it won't contain the value as either 0 or 1, but it will contain a probability value where it lies between 0 and 1. And when you use this particular function, so you put your data in this particular function, you will get a sigmoid curve. Okay, so you can find this threshold value. So now when you give a new data point with all the features, like the sex of the person, in our case we will give the sex of the person, and what is the P class, what is the ticket fare. So all this becomes our input features, and it will try to find this y. If the y value is greater than zero point 0.5, then the value will be 1. So 1 represents the people who have survived the Titanic accident. So if the y value, the prediction probability is less than 0.5, that means y is equal to 0. That means the person didn't survive the Titanic accident. So this is how it works. So in this case, we have only one feature right here, right? So in our case, we have about seven features, like the sex of the person and the P class, embarked ticket fare, etc. Right? So these becomes our input features. So in this particular graph, we have only two dimensions. So we have only one dimension for x, but in our case, we have about seven dimensions. So that is what you need to understand here, and this is how a logistic regression works. So the important thing you need to know about logistic regression is this is the sigmoid function on which logistic regression works, and it will give you a prediction probability value. And if the prediction probability value is greater than the threshold value, which is zero point 0.5, the value will be 1, and if it is less than zero point 0.5, the value will be 0, and this is used for our prediction. Okay. So now let's see how we can train this logistic regression model using this training data. So I'll create a variable as model, and in this model, let's load this logistic regression function. So we have imported this logistic regression function from sklearn.linear model, right? So I'll copy this. So let's put it here, and you need to mention parentheses. Okay, so this will load one instance of logistic regression model to this variable called as model. Okay, now we need to train our machine learning model with our training data. Here the training data is nothing but x train and y train. Okay, so this step will be training the logistic regression model with training data. Okay, so I'll use this model because this particular model will be now logistic regression will be stored in this variable called as model. So I'll use this model variable dot fit. Okay, so inside this we need to mention the training data, which are x train and x test. Sorry, x train and y train. Okay, so let's run this. This will train our machine learning model. So these are the different parameters which we are getting for our logistic regression model after we have trained it with our data. So this data set is a very small data set. We have about 891 values, right? So in machine learning and deep learning, we sometimes deal with data set which is very huge. We may contain several thousands of data, and even we may contain a data set which has lakhs of data points. So in that cases, when we are using this model.fit, when we are training the model, it will take a very long time. So this is a very small data set. It won't take much time. Okay. So this is how you can train your logistic regression model. And the final step which we have is to evaluate our model. So I have already mentioned you in the workflow that the final step which we do is evaluating our model. So this step is about model evaluation. Okay. And for this model evaluation, we will be using this accuracy score. Okay. So accuracy score. So if you remember, we have imported this accuracy score function from sklearn.metrics, right? So I'll just use this accuracy score function. So first, what we will do is, so we will just give this extreme data alone to our trained machine learning model, to our trained logistic regression model, and we will ask our model to predict what is the value of y that you can give. Okay, so this will give the value as either 1 or 0. That means the person has survived or not. So this is the prediction that is made by our model. So this will be accuracy on training data. Okay, so I'll just make an array called as extrain prediction. So these are the values that are predicted by our model. So for this, what we need to use is model.predict. So model is the trained logistic regression model that we have trained with our training data, which are x-train and y-train. And I'm using this model.predict. And inside this, just mention x-train alone. Okay, so what happens is now it will go through this x-train and it will try to predict the value as either 1 or 0. So this 1 or 0 represents whether the person has survived or not, right? So it is our target variable. So once we predict this value, so let's run this. So this will predict the values, and it will store all the predictions to extreme predictions. So you can try to print this value as well. So print extreme prediction. So these are the values predicted by our model. Here 0 represents the person didn't survey, 1 represents the person has surveyed. So these are the values predicted by our model, but we need to compare this with the original value. So original value is nothing but y train. So the original value and the one which are predicted by our model. So this is our accuracy score. So what is accuracy score is like comparing how many correct predictions our model is making. So I'll just create another variable as training data accuracy. Training data accuracy, and now here I'm going to compare the two values. So for this mention the accuracy score function which we have imported from sklearn.metrics. Here you need to mention two values. One is the original label. So the original label is nothing but y train, which we have splitted here, right? So y train. So mention the original values, which is y train, and the values which are predicted by our model. So these two values will be compared and it will give us our accuracy score for training data. Okay, let's run this. I'll also print the accuracy score. So print accuracy score of training data. So I'll just copy this training data accuracy and let's run this. You can see here we are getting an accuracy score of 80.75, almost 81 percentage. So 0.80 represents 80 percentage, and any accuracy of more than 75 is considered as good. So what is meant by this 80 is when you make 100 predictions whether the person has survived or not, your model will predict correctly for 80 times. So out of 100 you will get correct predictions for 80 values. So that is the accuracy score of our model, and every time we try to improve this accuracy with certain methods. So let's discuss about that later. So for now, understand that we can find this accuracy score by this using this accuracy score, and for this training data we are getting this accuracy score as 81 percentage. Now I already told you that we will evaluate our model with our test data. So we will train our model with the training data and evaluate our model with test data. So we have just uh, predicted only the training data, right? So now let's do the same for test data because the model didn't see the test data. So I'll just copy this here, and this is the accuracy score on test data. So this X train should be changed to X test, and this X train prediction should be changed to X test prediction. So if you remember, we have splitted the data, right? So into X train and X test. Now let's predict it for test data, which is X test. So model.predict X test. Okay, so now you can, if you want, you can also find or print the values of this X test prediction. So I'll just change this. So these are the values predicted by our model for test data. We know that test data only contains 171 values, right? So this is for the test data, and again you can find the accuracy score. So training data accuracy, so it should be replaced with test data accuracy, which we have found here. Okay, so test data accuracy is equal to accuracy score. Now we need to change this to a y test and x test prediction. So y test is nothing but the y values of x test. So you can see here we have splitted this data, right? So y test, y train and y test. So this is the original values of the test data, and we will compare it with y test and the prediction made by our model, and the prediction made by our model is x test prediction. So it is just a similar step. We just need to change the name of these values, and this is the accuracy on test data. And so test data accuracy. So when you run this, you will get the accuracy score. Here, the accuracy score is about 0.78, so 78 percentage. So you can see here the accuracy score on training data and testing data is not much different. So it is very close, right? If the two values is very different, let's say that if the accuracy score of training data is around 95 percentage and the accuracy score on the test data is around 40 percentage, that means our model has overfitted. So overfitting is and underfitting are some problems which we encounter in machine learning and deep learning. So I'll also mention you about those techniques and how you can rectify those issues when you are doing machine learning. So that will be in a later standalone video. So we cannot go detailing into that video. So what it means is when your model is overfitted, it tries to learn more from your training data and it doesn't generalize the idea. So I'll just give you an example for this. So let's say that a person is studying for a mathematics exam and he is practicing all the questions that are given in the mathematics book. So in exam, what happens is, um, examiner will ask questions that are not present in that book. So it is the good test for that person, right? So the student should answer based on his learning for new problems as well, not for those only present in the mathematics books, right? So that's what we are doing here. So we are trying to find the accuracy score on test data, where here the x train becomes the questions that are present in the book, and x test become the questions that are not given in the book. So if the value is more for the training data and it is very less for this test data, that means the student can understand the questions that are only given in the book. So he cannot answer the questions that are coming from out of the book. So we don't want that. So we want a good accuracy on both the cases. So that's why we are finding the accuracy on both the cases, right? So this issue is called as overtraining, where the accuracy on training data is very huge, and the accuracy for test data is very less. So that is about overfitting and underfitting. So let's discuss about that in later videos. And this is about our Titanic survival prediction. And here you can also make a predictive system. So I won't be explaining you that. So we have made several videos on how you can make a predictive system, where you will give all the values. So you will just give all the values, such as you can see here. So values such as P class, sex, age, siblings, parts, etc. So when you give all the values, your model can predict whether the person is survived or not. So we have already made that in several videos. So you can go through that videos, and you can by yourself can build a predictive system that predicts whether a person is survived or not. So it will be a good exercise for you, right? So just watching the videos won't help. So it won't give you a better experience. So what I'll suggest you is just practice all these codes by yourself and see how we can build this machine learning system. So before signing off, I'll just give you a quick recap of whatever the things that we have seen in this video. So the first step which we have did is import all the dependencies, so all the libraries we need. So we have imported the basic libraries such as NumPy, Pandas, Matplotlib, and Seaborn. And from sklearn, we have imported some functions which are train test splits and accuracy score. And we have imported this logistic regression model from this sklearn.linear model. So once we imported all the dependencies that we need, the next step that we did is data collection, where we downloaded this Titanic data from Kaggle, and we loaded this data to a Pandas data frame using this pd.read CSV function. And then we have printed the first 5 rows of the data frame using the set function. And then we have found how many rows and columns that we have in our data, and we got some information about the data and checked how many missing values we have in each columns. And also we have seen how we can handle these missing values. So we have dropped the cabin column because it contained missing values, huge number of missing values. And then we have replaced all the missing values in each column with the mean value. And we have also replaced the missing values embarked column with mode, which is the most number of repeated values. After that, we checked that we don't have any missing values anymore. And then we did some data analysis, where we just plotted the data in some plots and see how many values we have for each column, and how many people survived based on their gender. And after our data analysis part, we have encoded the categorical column, where we have replaced the text values with numerical values. And then we have splitted our features and targets separately. Features goes into X, and target goes into Y. And then we have splitted our data into training data and testing data. So we created these 4 arrays. So this is the step which we will do for every machine learning use cases. So we'll split our data into training and test data using this particular line of code. And then we have trained our logistic regression model with this training data, which is X train and Y train. And finally, we have evaluated our model with both training data and testing data, and we found an accuracy score of around 80% for both the cases. So that's it for about Titanic survival prediction. So I hope you have understood all the things covered in this video. So I'll see you in the next video. Thanks for watching.